Okay, we finished talking about the steps in the scientific method, and what I want to do now is spend some time looking at some of the different types of research design that psychologists use. And so, specifically, I'll talk about descriptive studies, correlational studies, which are a special type of descriptive study, and experiments. So, we'll look first of all at descriptive research. Let's look first of all at descriptive studies. Descriptive research is research that gives you descriptions of behavior, but not necessarily causal explanations. So it doesn't generally tell you why something happened. Rather, the focus is on understanding how something happens or on describing where it happens. There are different techniques for collecting data in descriptive research. These are things like case studies. So that would be a study with a case of one, which means that you do an in-depth study of one person. Observational studies. An example of an observational study might be, let's say that you're interested in aggression in children. Um, you're not going to find out necessarily why children are aggressive or what's causing the aggression, but you could go to a daycare or a playground and you could simply sit there and observe children and note how are they aggressive? What is it that they do? Do they hit each other? Do they pull hair? Do they yell at each other? Do they chase each other? Do they hit each other? That kind of thing. So it's descriptive, not it's not explaining why it happens in the first place. Another type of technique for collecting data would be psychological tests or surveys, and these are very commonly used in psychology studies. We have tests that measure all sorts of things. So personality tests, for example, have been developed, and they try to understand how you would describe someone's personality. Are they, for example, extroverted or introverted? Are they shy or not shy? Are they kind and agreeable and nice to be with? Or are they argumentative and hostile? And so this type of research doesn't explain why someone is kind or not, but it describes their personality. Similarly, surveys ask for subjects' opinions and experiences on a whole range of issues. They don't explain where those opinions come from, but they describe them. So descriptive research is all about understanding how something looks. When does it occur? If you're describing behavior, when does it happen? What does it look like? How long does it go on for? And that type of thing. In correlational studies, we're looking for relationships between two things. It's not going to tell us which one caused the other. What we want to know is, do two things tend to occur together in some systematic way? So an example here would be, let's say that you had 100 subjects and you wanted to understand the relationship, the correlation between the amount of time people spend watching TV and the amount of saturated fat in their diet. All right, so you have this idea that people who watch a lot of TV are maybe heavier than people who don't watch a lot of TV. All right, and your thinking there might be they're just not getting very much exercise. Okay, so you get 100 people and you get a measure of how many hours of TV per week they're watching, and you also get another measure of the amount of saturated fat in their diet. So if you have 100 subjects, each of them gives you two sets of data: hours of TV per week, amount of saturated fat in the diet. And you're simply looking for the relationship between those two variables. And so if you're right, and these people are, if you think there's a relationship and there is, then what will happen is, as the scores on hours of TV go up, then the amount of saturated fat that people eat in their diet will also go up. So in that sense, there's a systematic relationship between those two variables. As one scores on one go up, scores on the other go up. And of course it could be that as scores on one go up, scores on the other one go down. That's a systematic relationship as well. Okay, so in correlational studies, that's simply all we're looking for, is this relationship. It's not fair to assume that one of them causes the other, we can say that they co-occur, but we can't say that one causes the other. Now, I should tell you here that the word correlation is used in a couple of ways. We talk about correlational studies, and we also talk about a correlation. And a correlation is actually a number. It's derived from some very simple math, and it's a statistical measure of how strongly these two variables are related. So you can actually report this relationship in a number, and a correlation coefficient ranges between -1 to +1. And so you can have a correlation of 0.67, you can have a correlation of -0.32, you can have a correlation of 0, which means that there is no relationship between the two variables. Let's look at a positive correlation. And a positive correlation is a number greater than 0, and it can be as high as 1. So 1 would be a perfect correlation. We very seldom would find these in psychology studies. I think that'll become clear in a minute. But a positive correlation means that as scores on one variable go up, scores on the other variable also go up. So as an example here, let's look, and this is just a made-up example, let's look at two variables: final mark or final grade in class and hours per week spent studying. All right, so think about the relationship that you would expect to see there. It probably should be the case that highest marks in a class should be given to students who have spent the most time studying. Now, it's not going to be a perfect relationship, because we all know that there are some gifted people out there who don't have to study very much and still are able to get a high mark. We also know that there are some people who study a lot, and for whatever reason it doesn't pay off in terms of the final mark. So it's not a perfect relationship, as you can see on this graph, but what this graph shows is a hypothesized positive correlation between hours per week spent studying and final mark. And you can see that as hours per week goes up, at the same time, if you look at the red line, final mark is also going up. And so you would get this from looking at, let's say, 100 students, and each student would give you scores on two variables: their final grade and the number of hours per week they spend studying. So this is a graphic example of a positive correlation. And so the correlation coefficient here would be a number greater than 0 and up to 1. And it would probably be somewhere in the middle, like 0.45 or 0.5, something like that. Okay, let's look at an example of a negative correlation. And for a negative correlation, as the scores on one variable go up, the scores on the other variable are going down. Okay, so you've got your same 100 people, they're giving you two scores, and you're looking for a systematic relationship between those two scores. Now, in this one, I was trying to think of something that would have a negative correlation, and I came up with the idea of, well, I guess this is mostly for men: age and the number of hairs on your head. Now, we all know that there's a tendency for men to lose their hair as they age, and so this is a graphic example of a negative correlation between age, which is going up, and hairs on the head, which are going down. And again, this is a completely made-up example. It's not a perfect negative correlation, because we know that there are men who go into old age and still have a full head of hair. We also know that there are men who, when they're 17, 18, 19, start losing their hair. And so it's not a perfect negative correlation. Again, it'd be somewhere between -1 and 0. So a negative correlation doesn't mean no correlation. It means that scores on one variable are going up, scores on the other variable are going down. And the correlation coefficient will be between -1 and 0. There are lots of variables that, if you look at a pair of them, there's no correlation at all. And I tried to come up with something that would make sense here, and I came up with the number of fillings we have in our mouth, and the number of books we read per month. I couldn't think of any good reason why there should be any relationship between these two variables. And if you graphed the scores on here, so again, you have 100 people, you measure the number of their fillings, you measure the number of books they read per month, and then you graph all of that data. I am assuming that what we would find is a graph that makes no sense. It goes up, it goes down, it goes flat, and there's no correlation here. So in this case, we should see a correlation of 0. The correlation coefficient should be 0. Okay, so as a thought exercise then, see if you can come up with some examples of positive correlations, negative correlations, and no correlations. Experiments are done when researchers need to know cause and effect. And the experiment is the only type of research that allows you to make conclusions about cause and effect. And for that reason, the experiment is like the gold standard of research design, because all of the descriptive studies don't allow you to make this cause and effect conclusion. And in an experiment, the researcher has a lot of control over who's doing what. And the researcher is going to manipulate one variable to discover its effects on another. Now, manipulate one variable here has a slightly non-intuitive meaning. Let me give you an example. Let's say that you have designed a drug for depression. And so you want to know, does my drug actually alleviate depression? And so what you're going to do is take a large group of people who are suffering from depression, divide them into two, and half of them are going to get your drug for depression, and the other half are not going to get your drug for depression. And so let's say that over a 3-month period, people either take the drug for depression or they don't take the drug for depression, and then you look to see whose depression scores have gone down. The manipulation here, the manipulation of the variable, is giving one group the depression drug and giving the other group not the depression drug. So to put that another way, if you have 100 depressed people, 50 of them are going to get the depression drug, 50 of them are going to probably take a placebo, which is something that looks like a pill, tastes like a pill, but it's an inert, it just is a sugar pill. That's the manipulation. The manipulation of the variable there is that half of them get the treatment, half of them don't get the treatment. And what you're trying to discover then is the effect on the depression. In an experiment, you have different groups, and you have people doing different things in these groups. That is the manipulation. The subjects in an experiment are randomly assigned to be in a group. So in the depression study, all of your subjects would be depressed to begin with, and then you can't put all the men in one group and all the women in the other group, or the more severely depressed in one group and the less severely depressed people in the other group. They have to be randomly assigned to the groups, because the only thing that can differ between those groups is the manipulation of the variable, whether or not they get the drug. So there can't be any other systematic differences between the groups, otherwise you're testing more than one variable. So that the inclusion of a control group is very important. So you can probably begin to see some real differences between experiments and other types of studies. The experimenter has so much control over who's doing what. It tends to be a more expensive type of study. It may take longer to do. There's just a lot more experimenter control needed in this type of study.